In this video, we'll be going over the ways that we can combine functions using the four basic operations: sum, difference, product, and quotient. We'll also discuss how we find the domain of any of these combined functions. So first, just some basic definitions. The sum of two functions, well, we write that as, well, let's see, if I have f of x plus g of x, the shorthand and how we write that is f plus g of x. For a difference, we would say f of x minus g of x equals, well, how we will normally see this is f minus g of x. For the product, f of x times g of x, we'll see that as fg of x, and then for a quotient, f of x divided by g of x, we'll see that as f over g of x. So let's look at some examples to see how this works in practice. So let's let f of x equal x squared minus 6x plus 8 and g of x equal x minus 2. A couple of simple examples. If we see f minus g of 5, what this means is find f of 5, subtract g of 5. So f of 5, we have 5 squared minus 6 times 5 plus 8. We get 25 minus 30 plus 8. That's what, positive 3. And then g of 5, well, putting 5 into the g function, we have 5 minus 2, which is 3. So combining f of 5 minus g of 5, or subtracting, we have 3 minus 3, which is 0. So that's how we evaluate that. Let's do a second one. If we have f over g of 3, what this means is f of 3 divided by g of 3. So f of 3, we have 3 squared minus 6 times 3 plus 8. 9 minus 18 is negative 9 plus 8. We get negative 1 here. And then, so that's f of 3. And then g of 3, we have 3 minus 2, so that's just 1. So putting this together, we'd do negative 1 divided by 1, which is negative 1. Next up, we have f times g of x. And again, this just means f of x times g of x. So we're just going to multiply these two functions together. X squared minus 6x plus 8. Multiply that by x minus 2. So we have a trinomial times a binomial. So we're going to take each term in the first polynomial, x squared, we'll multiply by each term of the second polynomial, and we'll proceed in that way. So x squared times x is x cubed. X squared times negative 2 is negative 2x squared. Now multiply negative 6 times each term, so negative 6x squared plus 12x, and then 8 times each term, so we'll have plus 8x minus 16, and then we can simplify some like terms. X cubed minus 8x squared plus 20x minus 16. So that's what we would have here for fg of x. And then one last one, g plus g of y. This just means g of y plus g of y. So g of y is simply y minus 2. So we have that 2 times. So we're going to say y minus 2 plus y minus 2, and we get 2y minus 4. So 2y minus 4 here for g plus g of y. Now we want to talk about how to find the domain anytime that we combine two or more functions, but we're just doing two functions here. So how do we find the domain of two combined functions? All values of x that are in the domain of each individual function, wherever these domains intersect or overlap, this makes up the domain of the combined function. So kind of in a general sense, suppose we have a first function, let's call it f of x, and the domain of this is from 0 to infinity. So let's suppose this is the domain for f, and then for g of x, let's suppose the domain is, I don't know, from, let's say, -1 to 10 as an example. And let's say we include -1, but we don't include the 10. So this is the domain of the function of g of x. So if we were to combine these, what we'd want to do is think of the domain of the overlap here. Well, the domain of the overlap is going to be from 0 to 10. So when I put these together, we're going to say from 0 to 10. We're going to include 0 because 0 is in the domain of each, but we do not include 10 because 10 is not in the domain of g. So this is kind of how we go about finding the domain. One way you can do it is to draw the graph for each function and see how these intersect. Let's check out some examples. So let's go ahead and find the domain of each of these individual functions. Well, each of these are just regular polynomials. So the domain of f of x is going to be all real numbers. So -infinity to +infinity. Likewise, the domain of g of x is all real numbers. If we were to graph these side by side on a number line, we're going to say the domain for f of x is going to be all real numbers. And similarly for g of x, all real numbers. So when we combine these functions, everything overlaps here. Okay, so when we have f plus g of x, let's check out each of these functions. f minus g of x, and then f g of x, and f divided by g of x. So we'll combine these using the four operations, and let's see what each of those functions comes out to being. Okay, so when we combine each of these four functions, or each of these two functions in four different ways, what we get is what's seen here. Now let's look at each of these four results. So the first three results, we just get regular old polynomials. So what that means is the domain for each of these first three is just going to be all real numbers. So the domain for f plus g is going to be all real numbers, and the domain for f minus g is all real numbers, and the domain for f times g is all real numbers. Now things are going to be slightly different for f over g. While each of these individual functions is all real numbers, we need to be careful because x cannot equal +2 here, because if we input +2 into this combined function, this will be undefined. We'll be dividing by 0. So while the intersection of these two functions, or the intersection of the domain of these two functions, is all real numbers, we need to be careful because when we combine these functions, there's a value that we cannot put into the function, and that value is 2. So the domain here is going to be -infinity to 2 union 2 to infinity. So everything except 2 there. Now let's look at one last example of combining two functions and see what their domains look like. So two new functions, we have f of x equals square root x plus 2, and then g of x equals square root 5 minus x. So let's go ahead and find the domain for each of these combinations. But before we get to that, let's find the domain of each of these individually. So the domain of f, well, to find this, we take the radicand and we set it greater than or equal to 0. So x can be anything greater than or equal to -2. Looking at this on the number line, we'll cut off at -2 and we are above that. And then the domain for g, again, take the radicand, set it greater than or equal to 0. We get 5 greater than or equal to x. A lot of times we like to write the x on the left side, so x is less than or equal to 5. So on the number line, we're going to say x is everything less than or equal to 5. So there's the domain on the number line. Now let's go ahead and combine these functions by just what's asked for. So first of all, f plus g. So let's go ahead and actually find f plus g of x first and see what we get. So that's just square root of x plus 2 plus square root 5 minus x. Now we cannot combine these. These radicals have different radicands, so that's as simple as we can go. So there's nothing unique, or what I should say is we're not presented with a different form of this combined function from what we were given. We started with two radicals and we're ending with two radicals. So the domain here is going to be where these overlap. So the overlap, if we look up here, well, the values that are in each of these domains are going to be -2 up to 5, and we include those endpoints. So the domain of f plus g is from -2 to 5. Things are going to be very similar for f minus g of x. We're just going to have x plus 2 minus square root 5 minus x. Again, no form change, we just have two radicals. So the domain, again, is going to be where do the domains of each of these individual functions overlap. So this will, again, be -2 to 5, including those endpoints. And then the third one, f times g of x. Well, this is going to be square root x plus 2 times square root 5 minus x. I forgot the square root. Square root 5 minus x. Now when we have two radicals that we are multiplying, if the radicands are different, we can still multiply. So we could write this as x plus 2 times 5 minus x, all under the square root. So when we multiply this out, we're going to get square root of 5x minus x squared plus 10 minus 2x. Simplifying here, we're going to get 10 plus 3x minus x squared. Now, because this is a radical function, what we need is what's under the radical to be greater than or equal to 0. So what we need is 10 plus 3x minus x squared to be greater than or equal to 0. Now there's a couple ways you can go about this. One, we can find the critical values. In other words, where does this graph change signs from positive to negative? And that will happen. We can find that by looking at the graph. If we were to graph this, this is going to cross at -2 and +5, and this is actually something like this. So this function is negative here, it's positive between 2 and 5, it's negative greater than 5. So we want to know, when is this greater than 0, greater than or equal to 0. So this is going to be, the domain is going to be from -2 to 5. A second way you could do this would be to factor the radicand here. And if we factor the radicand, we're going to end up with just what we had in those two, x plus 2 and 5 minus x. So the critical values are going to be -2 and +5. Now I'm kind of running out of room. Let's go to another page. So the critical values were -2 and 5. And what we want to do is we want to see in each of these intervals, do we get positive or negatives? And we're going to get negative, positive, negative. We care about the positive interval, so we care about this interval right here. So that's -2 to 5. So backing up, that's exactly what we had here when we looked at the graph. And we can probably get to this point a little bit earlier because we can see what those critical values are. So it's important to go through this process just to check that radicand, see where that radicand is greater than or equal to 0, but we verified that kind of what we expected between -2 and 5 will be the domain here. Now when we're dividing two functions, this is when we need to be extra careful. Let's do g over f first. So g over f, this is just going to be square root 5 minus x over square root x plus 2. Now what we saw before, when we looked at each of these individually, we had a domain from -2 to +5. Now the only thing that is going to change now is that this -2, this is going to make g over f undefined. Because when we put in -2 right here, we get 0 in the denominator. We know that a function is not defined when we have 0 in the denominator. So what we would need to do is the domain here of g over f is going to be everything from -2 to 5, but we're not going to include the -2 because -2 will make this undefined. So there's the domain for g divided by f. And then lastly, f divided by g of x. So similar idea, we're going to say square root x plus 2 divided by square root 5 minus x. Again, we saw that this domain of each of these individual functions was -2 to 5. However, 5 now is going to be undefined, or make this undefined, because if we put a 5 in right here for x, we're undefined. So the domain of this combination, when we divide f over g, is going to be everything from -2 to 5, but we're not going to include 5 there.